7.6 Solving rational inequality. So solving rational inequality is very similar to solving uh, polynomial inequalities. Right? So in this case, we need to find out the zeros and then the uh, undefined, which before our critical point is only the zero. So the very first thing that you need to do is rewrite the inequality into one quotient on the left hand side and a zero on the right hand side. And then you're going to find out the critical point. In this case, because of this is a rational expression, the critical point will be including zero and undefined, which is the restriction. Right? Undefined, that's mean restriction. Zero and then restriction. We'll use this term. That would be better, right? Zero and restriction. Then we use those critical point to divide it into number line, divide the number line into intervals, and then we test the value for each interval to find out what is the solution is. So for this example 1, we already have one quotient on the left hand side and then 0 on the other side. So that allow us to find out our critical points, right? The critical points contain two things: 0, that is associating with the numerator of this fractions, which was going to be x minus 2 equal to 0, so x is equal to 2. So we know that our 0 is 2. And then we need to find out the restriction. The restrictions is basically which x value will make the denominator 0, so therefore the whole fraction become undefined. So that will be associating with the denominator part. And the restrictions, because of the restriction, this value can never be equal to 0. So therefore x value cannot be equal to -4. For the 0 part, it's going to be inclusive or not, that will be depending on the inequality symbol. So in this case, it's greater than or equal to. Okay? So now we're going to use that 0, these critical point to create the intervals on the real number line. So I have -4 and 2. And once again, critical this -4 is a restriction, so this will never be part of our solution. We put open circle. For 0, in this case, is inclusive. Okay, inclusive because the inequality symbol is greater than or equal to. Now we have interval 1, interval 2, interval 3. And we need to pick a number from each interval and then test it, which interval is a true statement. So in interval 1, I can pick -5. And interval 2, I can pick 0. Interval 3, I can pick 3, which is the smaller number is the better. And where do we check? We check in this inequality. Right? When the inequality is only one quotient on the left hand side and then right hand side is 0. When you substitute in -5, -5 minus 2, that will give me a negative number on the numerator. In the denominator, -5 plus 4, that will give me also a negative number. So a negative number times a negative number, that gives me what? A positive result. Right? So a negative number times a negative number, that gives me what? A positive result. So I know that a positive number is greater than 0, so therefore this interval is a solution. Now, checking on the next interval, when I substitute 0, the numerator will be negative because 0 minus 2 is negative 2. In the denominator, 0 plus 4 is a positive, and negative number divided by a positive number is a negative number. And we know that the negative number cannot be greater than or equal to 0, so therefore this interval is not good. And lastly, testing 3. So when I substitute 3 into our inequality right here, right? 3 minus 2 is a positive number. 3 plus 4 is also a positive number. So a positive number divided by a positive number is a positive number. And we know that a positive number is greater than 0. So therefore, this is also our solution. This interval is also our solution. Now, we're going to write the solution in terms of interval notations and the graph. So now, my interval notations will be from negative infinity to negative 4, not inclusive, union with 2 to positive infinity, 2 is inclusive, and then infinity is 0. My graph will be this, so from negative 4 and then 2. So this is open circle. So my graph will be everything right here and everything on the right side of 2. Let's take a look at on the next example. So in this example, we have to work a little bit more step, okay? Because notice that the right hand side is not 0. So according to the first step, we want to have one single quotient on the left hand side and a 0 on the right hand side. So that means first step I need to do is subtracting 1 on both sides. That will give me less than 0. Now we need to combine this 2 term into one quotient. So I need to have the least common denominator written down. So that will become 1. 1 is basically 1 over 1. I multiply top and bottom by negative x minus 3 to get LCD. So now I have 3x over x minus 3. And when I distribute the negative, that will become negative x and m plus 3. So when I simplify it, this becomes 2x plus 3 over x minus 3 is less than 0. Now the next step is, so this is the step that we put in first step, right? One left hand side, one single fraction, and the right hand side, 0. Now we're going to find out the critical point. Critical points include 0, and 0 is always associating with the numerator, which is 2x plus 3 equal to 0, and then I can find out x is equal to negative 3 over 2. And then restriction. The restriction is always the denominator part, right? Which value of x going to make the denominator 0. So I know that x cannot be equal to 3. That's the restriction. Now we're going to use this critical number and the restrictions to draw the interval, to break down the intervals on the real number line. So here is negative 3 over 2, and here is 3. And remember, the restrictions can never be part of your solution, so this will be open circle. Now, the 0 part is inclusive or not, that will be depending on the inequality symbol. This time is strictly less than, so therefore this is also not inclusive. So unlike on the first example, right? First example, we have greater than or equal to, therefore the 0 part is inclusive right here. Right? So now that we have this, we break it down into 3 intervals, interval 1, interval 2, and interval 3, and we pick a number from each interval and test it. So in this interval 2, I pick negative 2. In this interval, pick 0. In this interval, I will pick 4. And testing into this inequality, right? The inequality that have only one fractions on the left hand side and a 0 on the right hand side. So that way it's easier to uh, compare. So when I plug in negative 2 to the numerator, it will be negative 2 times 2, which is negative 4 plus 3 is a negative number. And plug it in negative 2 in the denominator will be negative 2 minus 3 is also a negative number. A negative number divided by a negative number is a positive number. And we already know that a positive number cannot be less than 0, so this is not correct. So this interval 1 cannot be solution. Now plug it in 0. When I plug in 0, the numerator will be positive number. When I plug in 0, the denominator will be negative number. A positive number divided by a negative number is a negative result. And we know that a negative number is smaller than 0, so this second interval is a solution because it's satisfied. Right? Remember, solution means it must satisfy the inequality or equation. So lastly, when I substitute 4 into numerator, that will become a positive result divided by, when I substitute 4 into the denominator, 4 minus 3 is also a positive. So a positive number divided by a positive number is a positive result. And we know that a positive number cannot be smaller than 0, so therefore interval 3 is not the solution. So finally, we found out the solution, so we're going to write down the solution in interval notation and also graphing. So negative 3 to 3, that will be my solution, and I know that negative 3 and 3 are not inclusive. My graph will be negative 3 to 3. Both of them is open circle, and then my answer is only in between them. And that will be our final answer. Continuing to the next example. So this one is already given to you the 1 fractions on the left hand side and a 0 on the right hand side. So we're going to try to find out the critical numbers, critical point. Right? And critical point contains 0 and undefined. Since the numerator has no variable, right? That means 1 can never be changed into 0. So therefore, in this case, we have none for the 0 part. Now we need to look at the restriction. The restriction is associating with the denominator, so it will be 2x squared plus 2x minus 8, and we know that cannot be equal to 0. So factoring out, that will be x minus 2 and then x plus 4. So we have x minus 2 cannot be equal to 0, x plus 4 cannot be equal to 0. So therefore x cannot be 2 and then x cannot be equal to negative 4. So we have 2 restrictions. Now using this restriction alone, we're going to create the intervals, which is negative 4 and 2. And both of the numbers are restrictions, so therefore they cannot be a part of the solution. So both of them will be open circle. And that gives us interval 1, interval 2, and interval 3. From each interval, I'm going to pick a number and then test it. So interval 1, I can pick negative 5. Interval 2, I can pick 0. Interval 3, I can pick 3. So now we know that the numerator is 1, so it's always going to be positive no matter what. Right? So we only need to check the denominator part. Let's check the easy one first, which is the interval number 2. When I substitute 0 into the denominator, 0 squared is 0. 2 times 0 is 0, so I will be left with a negative result. So positive number divided by a negative number is a negative. And then we know that a negative number cannot be greater than 0, so this cannot be solution. Now let's check on 3. So when I plug it in 3, so 3 squared is 9. 3 times 2 is 6. 9 plus 6 is 15. Definitely 15 minus 8 is a positive number. So therefore, a positive divided by a positive is a positive result, and we know that that is greater than 0. Same thing, same thing for negative 5. When I substitute negative 5, that will become 25 minus 10 minus 8. So that will be a positive result, which is going to become positive. So this is also good. So finally, I can write down my answer in this case, which is the interval notation will be from negative infinity to negative 4, not inclusive, union with 2 to positive infinity. 2 is not inclusive. The graph will be anything less than negative 4 and anything greater than 2 is my final answer. Example 4, the last example. This is basically using the function notations to talk about this rational inequality. So notice that I'm giving you the functions x plus 1 over x minus 4. We want to find out the x value, which is the function is less than or equal to 0. So that means we want to know the function value r of x is less than or equal to 0 and what x values will give us. So when we substitute the formula for function r, this is how it's going to look like. So nothing different than what we have done earlier. So right away, I can find out my critical point. Right? So my critical point contains 0, which is associating with the numerator. So we know that x is negative 1. And restriction, that is associating with the denominator. And we know that it's never equal to 0, so x cannot be equal to 4. Now from this, I can break down the real number line into interval using these critical points, right? Negative 1 and then 4. And we know that 4 is a restriction, so that's why never included, cannot be part of the answer. For 0, we have to check our inequality symbol. Since this is greater than or less than or equal to, we can have what? Negative 1 as a solution. So now I have 3 interval 1, 2, and 3 to find out which one is the solution. So I'm going to pick a number on each interval, and the smaller number is better, right? You can pick any, but so now I'm going to test it into this inequality. So when I substitute negative 2 on the left hand side, the numerator negative 2 plus 1 is a negative result. Denominator negative 2 minus 4 is also a negative result, which will give me a positive final answer. And we know that a positive number cannot be smaller than 0, less than 0, so this is not good. When I substitute 0, the numerator is positive, the denominator is negative. So positive number divided by negative number is a negative number. And we know that a negative number is 0 less than 0, so this interval 2 satisfies the inequality. And finally, when I substitute 5 into numerator will be positive. When you substitute 5 into the denominator is also positive. So positive number divided by positive number is a positive number. And we know that a positive number does not less than 0. So therefore, this interval is not satisfy the inequality. So finally, we found our answer, which is my final answer will be from negative 1 to 4. Negative 1 is inclusive and 4 is not inclusive. And the graph of this will be from negative 1 to 4. Negative 1 is inclusive, 4 is 0, and any number between that. And this concludes our section.